This video, we would like to talk about initial phase and, of course, altogether what is the phase itself, right? So, I would like to give you a little background of this simple harmonic motion so that you can understand it better. So, as you remember, we have proved earlier that vertical projection of uniform circular motion is simple harmonic. What is the meaning of that? There is a body in circular motion. So, if a body is in a uniform circular motion, say this is an origin, x-axis, x dash, y-axis, y dash. Uh, Assuming like the body is initially starting from the origin, draw a vertical projection at which O, so the displacement is equal to 0. When the particle reaches a particular point P, by making an angle theta with the x-axis, we need to draw a vertical projection like this, like I am drawing onto the y-axis. So from the origin, that vertical projection strikes the y-axis at a point P dash. Say from origin to that point, there is certain distance that is called displacement of the oscillatory motion, right? So this also becomes theta, and if you write sine theta, is opposite side of that y by this hypothesis, that is the radius, who is also the maximum possible displacement, which is called amplitude. So y can be written like a sine theta. That theta can be further written like angular velocity as d theta by dt. That is theta by t for a larger value. It implies theta can be written like omega t. That implies displacement can be written like y equal to a sine omega t. That's the equation for the displacement of a particle in simple harmonic motion. We have already derived it earlier also. I have just derived it once again, just to tell you the flow, right? So in all these, the important part is it has started from the main position. Yeah. Here it has started from the main position. So the angular displacement is theta is measured from main position itself. Mhm. The question is, what if it has not started from the main position? That's the point of the today's in this case lesson, this point. So it has not started from here, but initially it is already having certain angle. Let me show you with an angle something like phi. So it is not at x, but it is started from another point, say for example P. From here, the oscillatory motion is started. You are not started from the main position. That means even before you start, if you draw a vertical projection, it has some displacement already. Some value is already there. This value. Yeah. Yeah. This value is already there. Some position is already there. Some phi is already there. Mm. You have started rotation, it has gone to some another position P dash. You will draw a vertical projection. So uh, it is not started from the origin, rather it is started from here. From here to here is something like y1. From here to here there is something like y2. So the total displacement from the origin is actually not just y, like I have shown earlier, but y1 plus y2. Total angle is not just say this theta, but this phi is also there. So this kind of position, if it is already there, it is called initial phase. People also call it like echo. So that initial phase is already there, that is phi. that is above the x-axis. That means it has some positive displacement even before we start it. So everything, all the derivation remains the same. The only difference that I will get it is y equal to a sine omega t, like I have got here, the entire same derivation. Plus there is some initial phase phi. That initial phase is called something like omega. Why I have written a plus here? Because it has some angular displacement even before we start. It could start from, say, this position itself. In that case, this angle becomes 90 degrees. So, if started from extreme, that is extreme, right? So, this is origin, this is extreme, this is interim. For this oscillatory motion, this is the vertical projection of uniform circular motion is oscillating. The initial phase becomes 90 degree. Then y becomes sin omega t plus 90 degree. Then becomes cos omega. That's why a simple harmonic motion can be expressed either in terms of sin omega t as well as cos omega t. So be careful that if the initial displacement, initial phase is above the x-axis, we treat it like a plus. Suppose I just want to tell you one more possibility. Yeah, let's finish this so that we understand it clear. Suppose before the beginning of the journey, if it is having a phase phi below the x-axis, it has a negative displacement so that y will come, y1 will come here. So in that case, here it has a positive displacement, that's why I have written a plus phi. Here we will write y equal to a sin omega t minus phi. So plus phi means it's above the main position initially, minus phi means it is below the main position initially. So in general, we can write y equal to a sin omega t plus or minus phi. This phi is called initial phase. Omega t plus or minus phi is called total phase. That's phase itself. Be careful. If initial phase is not there, if the particle is starting from the main position, you won't get the plus or minus term. You will get it only if it has a initial position in simple harmonic motion. That's what's the meaning of the uh, phase and the initial phase. Hope you have got it. Thank you for trying.